Okay, so I just finished probing out or figuring out on the back side, on the harness side, the same three pins that I want to look at. So I've got the voltage supply for the solenoids, again voltage and amperage, and then I've got, this is the parking solenoid, and this is going to be, I guess, solenoid C. So I've got the scope running, and I quickly just open the door and close to make sure that the interior lights work, meaning that the battery connection was okay. You can already tell there's a pulse width there. That's the parking solenoid one. Red is amperage. I've got blue and green, they're overlaid. Blue is the main power feed for the solenoids, and there's green. So on the green, it's at its provided state that we are seeing on the control side. So it's going through the solenoid. So that feed is going through the solenoid, coming out the control side of that solenoid C. Now whether it tries to actuate or not, we will see once I get it running. Okay, mass airflow is installed. Now let it run till we get to the next capture, so I know where I'm starting when I go to hit some buttons. So right now I'll hit drive. It actually engaged and moved. I went back to neutral. I don't know if it's because the door's open. Let's see, where are we? Neutral. Let's hit reverse. I'm gonna hit reverse, and it's engaging. Wow. Okay. Let's see. Let's go neutral. Let's go to park. Okay, so park is not working. Let's see you drive. Alright, we're getting drive and reverse now. Alright, let me see. Okay, so quickly, this is that first portion where I hit drive. You can tell by the activity, so that's the green channel coming down, and then you can see where the amperage came up when the solenoid activated. It is up at just over 5.5 amps. Okay, so I've been messing with this off camera for a little bit. I broke out the scanner again just to see, and so we keep getting that shift solenoid valve C code come back. And off camera, I was able to, just like you saw, engage drive, reverse, I'll go back and forth until then go to park, and then after park, trying to go drive, reverse, it won't. It'll go back into that lock you out stage where it stays in park. I was able to get it to do that a few times, and now it's back to just fully not even engaging and moving. So what I think is going on is the computer is protecting itself. And normally I think I would mentally think about a high input as an unplugged connector deal, especially in the Honda world or many other makes, models. But I actually had the scope running. And so this last run where I started was trying to get something to happen as far as engaging and moving. It physically did not engage and move, but so I've gotten familiar at looking. So this portion here is when it starts, when I start, and then it runs. And then right away I try to hit drive again after starting it. So, but in this whole section that I did off camera, the vehicle did not grab, engage, and move. It just was doing the normal faulted state. Shorted, shooting straight up. I believe that as far as code description and what's going on, is that it is a true high input, meaning too much amperage possibly. I think overall what I'm gathering is that it's going into a protection mode, so it's keeping you in park. It's not letting you engage the solenoids to burn itself up. It's showing us a code about the high input, and it's not from an unplugged type high input, but a true high input back to the TCM in amperage form. And then I'm not going to worry too much on the stuck in park deal. Basically what I'm getting at is I'm going to open up the tranny, and I want to replace this solenoid. So I've done enough testing. I think I'm still going to go with gut feeling of opening up transmission, valve body, and hoping to get away with 2 solenoids. Also, one thing I wanted to point out before I get started taking it apart was the fact that I was able to go forward, back, until it got into that lockout mode. That helped me know everything from here to the TCM, and the TCM is intact and capable of providing and sending what it needs to actuate solenoids. Obviously it looks like the problem's going to be the solenoid, but up to this point, computer is not damaged. It's able to provide the command and actuate, so on and so forth. So there's no need to load test and all of that and worry about powers, grounds up there, this and that. So I am again thinking and gut feeling, but wanted to do all that testing before randomly going in there. So I just wanted to make that one note about the whole system. So there's a shot of the valve body installed and the basically contaminated fluid. So we'll just continue, get this pulled off, and see what we got. So obviously we have the valve body out and removed. It does have a bunch of sleeve tubes that tie it to the actual transmission. These two obviously came out with the valve body, but this is a dual speed sensor. This here is the basically park neutral switch deal. So that's what will tell you if it's at a park or not. This is actually what they call a transducer for pressure, obviously, measurement. This guy here is a temperature sensor. And then the main harness for all the solenoids down there. So, gonna identify some solenoids and take this connector housing apart and see what else we've got. Alright, so it's been a couple hours since I pulled off the valve body and set it down. I wanted to try to find out the solenoids that I initially thought was having issues with, and so things just started getting a little confusing based on what I thought was identified as solenoid XYZ from before. So I've sat down, I've probed and ohm tested backwards and forwards, so on and so forth. So I've gone there, and then I've touched these pins till I heard the meter beep, so on and so forth. I tried to identify the pin number to which pin here, which then tells me which solenoid, and then after that looking up these solenoids, so on and so forth. So I've got a lot of time trying to dissect and identify the solenoids, the pins, and what is what, because based off of what Honda had labeled, I was testing a little bit incorrectly, but I did capture the one that I was trying to capture, which was the shorted one. That is in fact true. So I've broken down as best as I can, and I'll try to explain. First, foremost, the labeling, as far as this goes, for the transmission computer module connector, it's not correct. The biggest example is going to be, well, shift solenoid C is not the solenoid C that I thought was going to be. So shift solenoid C is not even a shift solenoid like clutch C type of deal. And the parking lock actuator that I thought I was testing, I was not even testing the parking lock actuator. So this is, as far as the naming, is not 100% correct if you're trying to go by actual physical solenoids and their actual clutch designation. So I've got this. This is the actual, the printout is from Honda, and they don't give you specific labeling on their identification. They just give you generic statements other than parking lock actuator. That holds true. So here on the right is the true identifications for these 10 solenoids and their spec and the type of solenoid. So this one is an on-off type solenoid, and it's the highest ohm one. It's around 24 ohms. This is the spec. It's not what I've measured, but I'll show you what I get off of all of these. The next one down that they call just a solenoid valve is described as a park control, which that helps aid in the parking lock actuator. So this will get controlled, the park control solenoid will get controlled to push the valve, and then that will get actuated and it will lock and hold the valve. So it's a hydraulic assist for a mechanical movement, and that'll lock the valve. So that's what those two do. Next one down that they call pressure regulator is actually a clutch C, and the next one is a clutch D. And this one is pulse width, so let me write that. And it's 5.5, and the same with these two, 5.5 pulse width. The next one is what in this transmission is referred to, there's dog clutch and dog clutch, so it's F and A. That's part of where I was getting confused, but these are 11 ohms, so a little higher, and they also are pulse width. And then after that, clutch E, clutch B, torque converter, all of them pulse width and 5.5. And then lastly is the one that controls system pressure. It's pulse width and it's 5.5. So you've got 1, 2, 3, 4 actual clutch solenoids. And so once I saw clutch C as far as actual true solenoid location, and thinking that's what I was looking for, I went and ohmed that one. So I'll show you. So clutch C is 1, 2, 3, the third one down from the park lock. So here's the park lock. So 1, 2, 3. So it's this third solenoid. And so I'll get the leads in there. And we are pretty much close to what the spec is. And so that's where I started getting confused, because that was a 5.5, and then if we go to the one that's next to it, that's clutch D, and then we'll do clutch E and B. So it's 1, 2, 3, 4. So D, skip the next two, and then it's the other two. So we'll go right next door. And again, the same. So let me move the meter closer. So there's that. We'll skip these two and do these two. There you go, the same. And then I'll do the last of the clutch, actual clutch solenoids. And there you go. So all clutch solenoids are within spec, not shorted, and then that's where all the confusion started coming. So I just went down the line. I'll show you what readings I'm getting from all the solenoids. So that's the park lock actuator solenoid, right at where spec goes, right at 24. This one is the park control, and we are at 3. We'll do, this is the dog clutches, A and F. So that's pretty much close to 11. We'll do the second dog clutch. Same deal. This was clutch. And then this one was the torque converter. So that's within spec. And lastly is that system pressure. And that one also is a within spec. So all of them were good except for this second one. Which right now we are at 3. That should be 5.5. But so the second one down again, like we said, it's part control 5.5. That one is the one that is shorted. And so when we then pin this out to the round connector, I'll show you where those two go. Okay, so I am in pin 11. And then we know it's the second one in. So there you go. So second solenoid, the control side goes to pin 11, which we were testing earlier. And the other side of that pin is going to be number 1. So there's number 1. We'll go here. So there you go. So it's 1 and 11 as far as this round connector, which I've labeled here 1 and 11. We know where 1 goes to, or is described as, and that's the power source, like we were testing earlier. And back to where we were testing at 11, it's described as this solenoid C. So let me try to clarify as far as all of it can get tied in together. So the only solenoid that is out of spec or shorted or lower ohms is this second one. When pinned out to this round connector, it's pin 1 and 11. We find 1 and 11, it's power supply, which is constant for 6 different solenoids, which is basically this sheet here. There's 1, 2, 3, 4, 5, 6. Voltage supply, pin 1. And 11 is, because we identified it, goes to that one, which is part control in actual physical position. And what it really is, it's a part control solenoid. But Honda calls it solenoid C. Trouble codes. We're getting solenoid C high input codes. So it's not a shift solenoid C like I was thinking, or someone would probably normally think. It's just, I guess, they're labeling for that position, and it happens to be the one that is a part control solenoid. Now, if you remember that second code, the stuck in park deal, I was almost disregarding it because I was concentrating on shift solenoid C, or what I thought was for like a clutch C solenoid. But overall, so basically what is going on, it's losing ability to control, or we have the lack of control for parking, actuation, or locking. And so that's why at times it let me get out of park and move forward back, but then once I went back in park and or neutral, since we have a lack of control because of the shorted solenoid that controls park, it stops you from doing anything and moving that solenoid. And then if you remember, I went from 1 to pin 2, which was what I was thinking is like a clutch A type solenoid. It was actually pin 2 was going to one of those dog solenoids. So 2 and 8 are the two middle ones, which are the dog solenoids. These two different colored ones. Not an actual like shift solenoid, but the ohms that I got to pin 8 is 11, which that's correct. And then I had that weird high reading on pin 2, which is the other dog solenoid. And I think I was getting weird possible reading because of not only are we dealing with a shorted solenoid, but we have the incorrect fluid in there. And I'm wondering if that was, let's call it tampering with the readings as far as what's going on, because here on the bench, tapped into all of them, I am getting the correct 11 ohms from both of those. So there's just an added thing that's, I believe, making things a little bit difficult. I mean, lastly, I can reinstall this and tap those two and make sure that there's not high resistance that way through the harness. But as far as what's truly going on is that I believe, is that I know for sure that we do have a shorted solenoid, and it is the one that we captured on the scope from, and the waveform shooting straight up gives that, lets us see that. And as far as trouble code being generated, as far as solenoid C on the scanner, it, I guess, truly is identifying that solenoid because it's pinned out correctly to the one that's shorted. So it's a little bit backwards or whatnot, but that is what's going on. So, and I'll put this up if anyone down the line needs to look at this. This is the pinout for the solenoids in that order at the round valve body harness connector. And as far as what they are in control, I'll put this here, and you can go by that. And so to kind of just prove out the theorized statement that I just made, here is the connector back on the solenoids. I am on pins 1 and 2, and there is your 11 ohms, which when I went to 2, we had that crazy high spec. So without it being in the contaminated fluid, we are getting the correct reading through the harness from pin to pin, and it's within spec. So again, one actual true solenoid shorted, and and before I forget, let me explain, because we saw that in what this was another incorrect identification. When I tapped into this one, which was listed as the park lock actuator, thinking that I am there, we saw a constant pulse width all the time. And that is because we were not even on the solenoid for the park lock actuator. So as far as, so pin 9, if you look and see where pin 9 goes, it's the last one on the bottom, which is a system pressure solenoid. So that one which makes sense, is going to constantly be pulsed for pressure control, basically. And so that park lock actuator, pin 9, is not park lock actuator. It's a system control. As far as park lock actuator, it's pin 12, which then pin 12 goes to 51, which is listed as a SHD pressure regulator. So that naming as far as this list is not even correct. But when it's pinned out, we can identify and know that the park lock actuator labeling is not correct, and that's why we saw that the pulsing, and we were never on 12 to check that park lock actuator, but I'm going to assume that that's good. The second one is the one that's faulted, which is aids in control of the park, and then that bottom one was the constant pressure control for the system.